All right, so we're just going to do a brief little introduction here for what is section 1210. And we talked about solving systems of equations, primarily systems of linear equations. You learned that last year in Math 1. And what we're going to introduce now is solving a system of equations when we have a line and a quadratic. Okay. So when we have a line and a quadratic, it means we have a parabola and then we have a line. All right, so we can have this situation right here. And obviously this here, we're going to have two spots where those cross. So that's going to give us two solutions. And, the parabola could be pointing down, also up. The line could have a positive, negative slope, but basically they cross over each other twice. We can also have the situation where I have the parabola, and my line only touches it at one point. This is similar to when the vertex only touches the axis at one point. So this is just going to give us one solution. And then, just like when we have two lines, we could also have a parabola here, and then maybe our line is completely here. So they never touch at all. And in this case, we have 0 solutions. Okay, well, we still have our same methods for solving. We can solve by graphing, we can solve by elimination, and we can solve by substitution. So graphing, we know if we have access to Desmos, we can use that. And with our graphing calculators, we can do that as well. We'll talk a little bit more about that when we can kind of do some examples. But let's take a look at one example when we want to solve first by elimination. So solving by elimination. And this is my system. Y equals 28x plus 4, and y equals negative x squared plus 39, 39x plus 64. Okay. All right, so first thing I'm going to do, elimination. We know we want to eliminate one of our variables. So one of the variables to go away. Well, 9 times out of 10, that variable is going to be the y, okay? Because these are going to be set up as y equals. So the coefficient in front of the y is going to be the same. I just need to change the sign of one of those. So I need to multiply one of these equations by -1 to change that sign. So I'm going to multiply the second one. So first one's not going to change. Y equals 28x plus 4. And now my second equation becomes negative y. And multiply this one by -1. So we get a positive x squared minus 39x minus 64. Now I can add these two. Notice I kind of left a little space in that first equation there where the x squared was, just so I could have my like terms lined up here for me. So now when I add y minus y, well, that's 0. X squared negative, or 28x minus 39, negative 11x, and 4 minus 64 is negative 60. All right, and now we have our quadratic, which I know all of you are super happy to see, again, that we're solving quadratics here still. This fact hasn't gone away. That is why all of this is still in the same chapter here. So now we want to look at this quadratic and think, okay, how am I going to solve this quadratic? All right, well, we have our different methods here. We have quadratic formula. We have completing the square. We have factoring. Okay, so look at this here. Factoring is always a way that we like to start because it just makes things a little easier for us. So we'll see if we can factor this. So negative sign second, so my signs are going to have to be opposite. And then I know, do I have two things that I can multiply for 60? but that I can combine or have a difference of 11. Well, we can try different options here, and it turns out that yes, there is 15 and 4 multiply to 60, and they have a difference of 11. Now I want to have a negative 11, so I want the 15 to be negative and my 4 to be positive there. All right, and I can always, as we know, multiply these two back together and verify that it equals with what I started with there. But now we know our answers to this are x equals negative 4 and x equals positive 15. But now here's the big difference when we're doing this, when we're solving a system, okay, as opposed to just solving the quadratic. When I was solving the quadratic, that was enough. I had my two x values, and that was it. But going back to our picture here, okay, we see that our solutions here, okay, well, they're when these cross on a graph, okay? These aren't just x-intercepts anymore. So these solutions need to have both an x and a y with each one. So I need to take these x values, each one, plug them into one of my original equations. I would recommend the first one because then you don't have the x squared part, to get the y that goes with that. So we're going to plug negative 4 in here. So y equals 28 times negative 4 plus 4. All right, well, 28 times negative 4 is 112. And negative 112 plus 4 is negative 108. So this point is negative 4, negative 108. My other point then, we plug in 15, do the same thing. Y equals 28 times 15 plus 4. So we have 420 plus 4. So y equals 424. So that then is the point 15, 424. So those are our two solutions, our 2 points where this line and this parabola are going to cross. We can also solve a system with a linear and a quadratic by using substitution. Let's do solving by substitution. And again, the y's kind of become the important part here. So if we have the equations y equals x squared minus 6x plus 10, and y equals 4 minus x. So on the elimination, where was the y's that we wanted to eliminate, well, we see here also with the y's, both of these equations are already solved for y. So essentially all we have to do is take our two equations, x squared minus 6x plus 10, and set them equal to each other. Equals 4 minus x. Since they're both equal to y, they can both be set equal to each other. Now here, it's a quadratic, so we want to have it set equal to 0 to solve. So I will add x and subtract 4 from the right, which means I will add x and subtract 4 from the left also. So we'll get x squared minus 5x plus 6 equals 0. Now again, we want to look at our different methods for solving quadratics. If we can factor, usually that's going to be our easiest one. It turns out here, again, we can. All right, so x and x, plus as my second sign, minus as my first, means my signs will be the same, and they will both be negative. Now, two things that multiply to 6 and combine to 5, well, that is 3 and 2. So this means my two solutions are x equals 3 and x equals 2. Now the same with when I did elimination. I now need to take these values, substitute them into one of my original equations. Again, I would recommend using the linear equation since there's no x squared term in there. But if I plug 3 in, y equals 4 minus 3. y equals 1, so that gives us the point 3, 1. And substitute 2, y equals 4 minus 2, so I get y equals 2, which gives us the point 2, 2. And those are my two solutions there for solving those systems. Okay, so that's just a brief introduction there to show us how we can solve systems when we have a linear and a quadratic by graphing, by elimination, and by substitution.